Welcome back to my teachers program. We will be continuing our revision. Now the next one I will be discussing with you is vector addition. First I will briefly explain what is parallelogram law of vectors and how it helps us to find out the magnitude of the resultant. Now according to the parallelogram law of vectors, if the two adjacent sides of a parallelogram represent in magnitude and direction two vectors A and B, then the diagonal of the parallelogram gives the resultant in magnitude and direction. If this resultant makes an angle alpha with the vector A, then we can relate A and B and C, and thus we can also express this C in terms of we can express C magnitude wise as C is equal to root of A square plus B square plus 2AB cos theta, where theta is the angle between the vectors A and B. Once again, according to the parallelogram law of vectors, if two adjacent sides of a parallelogram represent two vectors in magnitude and direction, then their resultant is represented completely by the diagonal of the parallelogram. The magnitude of this parallelogram is magnitude of the diagonal is given by root of A square plus B square plus 2AB cos theta. Thus C gives the magnitude. Now how to find out the direction? We can see in the figure clearly that the C is making an angle alpha with the vector A. Tan of this angle is equal to B sin theta divided by A plus B cos theta. This alpha represents the direction of C with respect to the vector A, that is tan inverse B sin theta divided by A plus B cos theta. Thus we can easily find out the resultant of these two vectors by using the parallelogram law. You should also understand that certain tips which I am going to mention right now. When you are given two vectors, the maximum magnitude of the resultant will be always the sum of the vectors. This happens when the angle between them is 0 degree. That means when both the vectors are acting in the same direction. If A and B are in the same direction, the resultant will be given by, vector wise it is given by C is equal to A plus B, magnitude wise it is given by C is equal to A plus B. This is the maximum value of the resultant of two vectors that happen when the angle between them is equal to 0 degree. And minimum value of the resultant of two vectors occur when they act in opposite direction. So if we are considering vector A and vector B exactly in opposite direction, the angle between them will become equal to 180 degree. You can cancel the effect of one of the vector with the other vector if they are equal in magnitude and opposite in direction. Then the net resultant will become 0. Otherwise, if A is greater than B, then the resultant is given by A minus B. So minimum value of the resultant between any two vectors is given as C minimum is equal to A minus B, which is happening when the angle between the two vectors is equal to 180 degree. Never the resultant of two vectors can be more than the maximum value and less than the minimum value. For any other angle, the value will come between these two. And I can give you one simple example of such a problem. Like for example, if you are given two vectors have values 8 units and 6 units. What is the maximum resultant possible for these two vectors? If you are given the value of vector A, magnitude of the vector A is 8 units and the magnitude of vector B is equal to 6 unit, then the maximum value of the resultant is 8 plus 6, that is equal to 14 units, and the minimum value of these two vectors will be equal to 8 minus 6, that is equal to 2 units. They can never have a resultant more than 14 and less than 2 units. Is clear? So thus we can make use of the parallelogram law of vectors in order to find out the resultant of any two vectors which are making an angle theta. Now we will go for a very short break before I come back to this slideshow, and we will do some extra questions based on the topic.
Very good morning and namaskaram. നമ്മളുടെ ചുറ്റും നടക്കുന്ന ഒരു പിടി വിശേഷങ്ങളുമായി പത്രവിശേഷങ്ങളും നിങ്ങളുടെ പ്രിയപ്പെട്ടവർക്കായുള്ള ആശംസകളും. NTV-യിലൂടെ ആകട്ടെ നിങ്ങളുടെ പ്രഭാതം. ഒരു കപ്പ് കാപ്പിയുമായി നമുക്കൊന്ന് ചിരിക്കാം. ഡെയിലി മോർണിംഗ് 9 AM to 10 AM.
അടുത്ത സാറ്റർഡേ സ്കൂളിലാണ്
Oh, good.
പക്ഷെ മമ്മി വന്നാ മതി, പപ്പ വന്നെന്റെ പെൻസ് കളയാക്കും.
Bring back the happiness in your life. Gulf Kate Hair Fixing. Look natural. Feel natural.
Welcome back. Let us begin the remaining questions based on the vector addition. See the first question, please. When is the magnitude of a plus b equal to the magnitude of a minus b? When is the magnitude of a plus b equal to the magnitude of a minus b? Let us solve this one. The question is, when can a plus b's magnitude be equal to a minus b? A plus b's magnitude can be found as root of a square plus b square plus 2ab cos theta according to the parallelogram law of vectors, and a minus b is root of a square plus minus b the whole square plus 2 into a into minus b cos theta. I hope you understood why I have used minus b here, because it is given a minus b. In vector addition it is actually a plus of minus b. That is what is meant by a minus b. Now when you square both sides of the equation, you have a square plus b square plus 2ab cos theta is equal to a square plus b square minus 2ab cos theta. A square and a square cancel, b square and b square cancels on either side of the equation. Take this 2ab to the left side, you have 4ab cos theta is equal to 0. You know that 4 cannot be equated to 0, a cannot be, a may or may not be, b also cannot be equal to 0. Then we have cos theta is equal to 0, and when does cos theta become equal to 0? When theta is equal to 90 degree. Thus it shows that the magnitude of a plus b and a minus b can be equal only and only if the angle between them is equal to 90 degree. Now we will go to the next question. When the angle between two vectors of equal magnitudes is 2 pi by 3, prove that the magnitude of the resultant is equal to either. Okay, let us see how we can do it. You have to show that a equal to b, when a is equal to b and when theta is equal to 2 pi by 3, the answer which you are going to get is also found to be equal to either a or b. Let us assume that a is equal to b is equal to x. Theta is equal to 2 pi by 3. What is the meaning of 2 pi by 3? 2 into 180 degree by 3, that will be equal to 120 degree. Now using the normal equation of c is equal to root of a square plus b square plus 2ab cos theta, we can find out the value of c. Root of a square is x square, b square is also x square, plus 2 into x cos theta, correct? And the value of that cos theta is already given as cos 120 degree, that is root of x square plus 2x square cos 20 is minus 2, because it is in the second quadrant, and in the second quadrant only sign is positive, cos is negative, cos 120 degree is equal to minus half. If you cancel this 2 and 2, you will get the root of x square, that means the answer is equal to again x, that is root of 2x square minus x square, that is equal to x square. This clearly shows that if two vectors are identical and the angle between them is 120, even the resultant is equal to either of them magnitude wise. Now let us continue with the next question. Two forces, one with a magnitude of 4 Newton and other with a magnitude of 7 Newton, are applied to an object for which orientation of the forces is the magnitude of the acceleration of the object the least. Give the reason for your answer in one line only. Yes, you are given in the question that there are two forces, one has a magnitude equal to 4 Newton, another has a magnitude equal to 7 Newton. When is the acceleration the least? This is based on the fact that I explained to you, the resultant of two vectors can never be lesser than the difference between the two vectors. Difference in magnitude of the two vectors, minimum resultant will be always the difference, and therefore the minimum value of the force will be when F minimum will be when this 7 Newton and 4 Newton are acting in the opposite direction. And what is the minimum value? 7 minus 4 is equal to 3 Newton. When the force is minimum, of course MA minimum is equal to 3, so the acceleration also will be the least. So acceleration is the least when the two forces are acting in the opposite directions. Now let us have a recap of whatever we have done with a very small slideshow, please. Once again I am coming back to the slideshow. There is some technical problem in the showing of slide. Let us continue with the projectile motion and we will come back to some questions based on the projectile motion. Now let us consider about the projectile motion. What do you mean by a projectile? What are the two kinds of motion possessed by a projectile? A projectile is any object which is projected into air by making an angle with the ground. This kind of projectile, which is projected with a certain angle with the ground, has two independent motions. One motion along the horizontal direction, which is of uniform motion, and another motion which is along the vertical direction, which is an uniformly accelerated motion. So a projectile motion is consisting of two independent motion, an accelerated vertical motion and a uniform motion along a horizontal direction. The maximum height covered by a projectile is given by h max is equal to u square sine square theta divided by 2g. The range of a projectile means what is the maximum horizontal distance covered by a projectile. The horizontal distance of a projectile r is given by u square sine 2 theta divided by g. It starts the journey from a point here and it ends the journey here. The time taken to complete its journey is called by the name time of flight of a projectile. The time of flight of a projectile is given by 2u sine theta divided by g. For a projectile, There are two kinds of motion, a horizontal uniform motion and a vertical, what we say as uniformly accelerated motion. And this horizontal uniform motion shows very clearly that throughout the motion the velocity of the projectile along the horizontal direction remains the same, but for a vertical motion the velocity will decrease first and then increase. So velocity changes along the vertical direction. Now for a projectile motion, the time for it remains in air is given by 2u sin theta divided by g. The maximum height covered by a projectile is given by u square sin square theta divided by 2g, and the range of a projectile is given by u square sin 2 theta divided by g. This range of a projectile will be maximum when you are projecting at an angle of 45 degree. A given projectile at a given velocity can cover same range for two angles of projection. The condition required for it to cover two angles of for covering the same range for two angles of projection is these two angles sum should be equal to 90 degree. We will be doing some problems based on projectile motion also today, because this projectile motion I have just now mentioned that it is consisting of two independent motion. One is along the horizontal direction, it has a uniform velocity, and along the vertical direction it has a uniformly accelerated motion. And we have seen that the time for which a projectile remains in air is called as its time of flight. The maximum horizontal distance covered by a projectile is called as the range of the projectile, and the maximum height means the vertical distance, maximum vertical distance covered by a projectile is called as h max. Now let us see what will be the ratio of the time of flight and the ratio of the height of a projectile when it is covering the same range. Okay. Now I told you that a projectile covers the same range when one of the angle is theta and the other angle will be equal to 90 minus theta. That means when theta 1 and theta 2, when you add, you have to get 90 degrees. Such angles are called by the name complementary angles. That means if one is theta, then the other angle will be equal to 90 degree. Now under this condition, what is the ratio of the heights covered by it and what is the ratio of the time of flights covered by it? To find out the time of flights ratio in the two cases, in the first case you have 2u sin theta divided by g. In the second case you have 2u sin 90 minus theta divided by g, that is equal to sin theta is to cos theta. This is same as writing as tan theta is to 1. So the ratio of the time of flight when a projectile covers same range for two different angles of projection will be given by T1 is to T2, that is equal to tan theta is to 1. Under the same condition we can also find out the ratio of their height maximum covered. H1 is to H2 is equal to u square sin square theta 1 divided by g is to u square sin square theta 2 divided by g, that is u square sin square theta sin square 90 minus theta divided by g. Here we have sin square theta is to cos square theta. What is sin square is to cos square theta? Tan square theta is to 1. So thus when a projectile covers the same range for two different angles of projection, how can we find the ratio of the time of flight? How can we find the ratio of the heights covered by them? And in this same condition you can see that when you add the heights covered by them, the heights covered h1 is to h1 plus h2. If you are adding, the first case you are covering h square is h1 is equal to u square sin square theta divided by 2g plus u square sin square 90 minus theta divided by g. In this case you can see u square by 2g can be taken common. You have sin square theta plus cos square theta. Sin square theta plus cos square theta is equal to 1, that is u square divided by 2g. This is clearly showing that when you add the heights when it is covering the same range for two different angles of projection, we get the value u square by 2g, which is independent of the angle with which it is projected. It is only depending on the velocity and the acceleration due to gravity. Now we will continue with a few more questions. Let us go for a slideshow, please. Just observe the next question, please. A cricket ball is being thrown at a speed of 20 meter per second, making an angle 30 degree with the ground. Calculate the maximum height, time taken by the ball to return to the same level, the distance from the thrower to the point where the ball returns to the same level. These three questions are very direct questions. You can see very clearly in the question itself that you can calculate the value of the maximum height, time of flight and the range. It's a very direct question. You need to use directly the equations. To find out the time taken, you can use directly 2u sin theta divided by g, and the value of the u is given as 20 meter per second and the angle is given as 30 degree with respect to the ground. Similarly, you can easily find out the value of the h max, that is equal to u square sin square theta divided by 2g, and the range you can find it using sin u square sin 2 theta divided by g, using the same the equations directly. So you need to just substitute this 20 meter per second into that equation, and theta is equal to 30 degree, and g you can take it as 10 meter per second square as it is given in the was given in the question. Okay, let us proceed with the next question after a short break.